Alright, in this question, okay, you are first told that you may use the expansion from MF26. So this tells you that the Maclaurin's expansion in MF26 is going to be very important. Okay, now next you need to find the Maclaurin's expansion of ln cosine 2x in ascending powers of x up to and including determined at 6. Right? Remember, x6 is the highest power that you need. Now next you need to state any values of x in the domain from 0 to pi by 4 for x in which the expansion is not valid. So this expansion is referring to Maclaurin's expansion. Okay, we'll talk about this later on. In the second part of the question, you are told to use your expansion in part 1. So that's the first instruction. And integration. So 1 and 2 must be used to find an approximate expression for the indefinite integral. Right? Then hence find an approximate value for the definite integral. Okay, giving your answer to 4 decimal places. So this is the accuracy requirement. Right? And not forgetting, there is one part that tells you that hence means you got to use that whatever you have found. Alright, next, you are told to use your graphing calculator to find a second approximate value for this definite integral, giving your answer to 4 decimal places. Again, this points to accuracy. Okay, let's look at part 1 of the question. Okay, now some of you might be very familiar with your Maclaurin series and see, hey, I have the expansion for ln 1 plus x. So is it possible, alright, for me to say ln of 1 plus cosine 2x is equals to 1 plus cosine 2x, right? Is it ln, does it mean that I can just immediately replace this by cos 2x minus cos 2x square over 2 plus cos 2x cubed over 3 minus so on and so forth? The answer is no. This is a big no-no. Alright, now in order to use the Maclaurin's expansion, notice you can only replace this x here. Okay, so you can only replace it by either a polynomial or a multiple of x, all right, or a polynomial of x essentially. Okay, because if x is small, right, then the polynomial in terms of x will also be small. Okay, now, before I can find ln of cosine 2x, I will then need to find the expansion for cosine 2x. So how do I find cosine 2x? I need to find the expansion for cosine x first, which is provided by MF26. Right, so for MF26, this is what you have. Then, in order to find cosine 2x, I replace the x that you see here with 2x. And that's how I obtain the Maclaurin's expansion for cosine 2x up to x to the power of 6. Right? So, with this in mind, looking at the expansion of ln 1 plus x, again, from MF26, okay, we now move on to find the expansion for ln cosine 2x. So this expansion here is exactly what you saw over here, up to the power of 6. So I can re-express this as ln 1 plus negative 2x squared plus 2/3 x power 4 minus 4 over 45 x6. Alright, notice the difference in usage. This is approximation because this is an approximated expression, and this is equivalent because this entire expression here is exactly the same as what is before. Okay, so be careful when you use the approximation and equivalent sign. Now, then, notice that in the expansion of ln 1 plus x, there is power 1, power 2, and power 3. How do you know when to stop? Okay, now for power 1, when you replace x with the expression here, it's quite simple. The powers of x is just x squared, x4, x6. Now let's take a look at this expansion, the one that I just highlighted in green. Alright, now for negative 2x squared plus 2 third x power 4 minus 445 x power 6 to the power of 2, this is actually a binomial expansion. So how do you find the range of indices of x? Right, so the possible possible powers of x, all right, is actually x squared, the lowest exponent term square, which is x power 4, to x6, the highest, to the power of 2, which is x12. So since your the exponents of x can range from x power 4 to x power 12, and it is before you hit x to the power of 6 that is required, you will still need, I repeat, you will still need this particular expansion in green. Similarly, right, let's take a look at this expansion in blue, right? Negative 2x squared plus 2 third x power 4 minus 445 x6 to the power of 3, right? The lowest power of x to the power of 3 is x6. The highest is x6 to the power of 3, which is x18. So actually, you just need the x power 6 term from this particular expansion. Okay, so you will need to work out a little. Now, how do you actually expand? Let me show you the first one. For negative 2x squared plus 2 third x power 4 minus 445 x power 6 squared, you can actually do it by grouping the terms, negative 2x squared plus 2 third x4 minus 445 x6 to the power of 2. Then this becomes a squared plus 2 times 2x squared times 2 third x power 4 minus 445 x6, alright, plus 2 third x power 4 minus 445 x6 squared. Right, so you notice that the x6 and x4 terms will come from this term. This term will be x6. If I took negative 2x squared multiplied by this is x to the power 8, which is not required. In this expansion, I have x8 to x12, right? Same thing, x4 to the power of 2, x6 to the power of 2. So this is also not required. So I only need the terms in blue. Okay. Then finally, sorry, this one is wrong. Okay, there's no such term here. Then finally, the last one, negative 2x squared plus 2 third x power 4 minus 445 x6 to the power of 3. Same thing, you group them up. Alright, and then you expand using binomial expansion. Right, then you take the relevant terms, negative 8x6 over 3. Okay, you expand and you simplify. So this would be the answer for this part of the question.
Right, so state any values of x in the domain for x between 0 and pi by 4, okay, for which the expansion is not valid. Okay, so we look at the function ln cos 2x. Right, because it's the function of logarithm, all right, if we look at ln of fx, right, it's only defined if fx is positive. Right, so for the expression not to be defined, then we just need to check when this is equals to 0. Okay, because ln 0 will be undefined. All right, so for that to happen, cosine 2x is equivalent to 0. So in this case, x is between 0 to pi by 4. So 2x is between 0 and pi by 2, which is in the first quadrant. All right, so in this case, if 2x equals to 0, the only time it will happen is when 2x is equals to pi by 2, and therefore x is equals to pi by 4. So this means that the expansion is not valid when x is equals to pi by 4. Okay, so it also means that there is no way your Maclaurin's expansion, okay, could be used to find an approximation for this function ln cosine 2x when x goes to pi by 4.